They are basically reusable modules of code that can be used repeatedly to perform a specific function. That is the definition of your functions, right? So now coming to the syntax of functions in Python, it starts with the keyword called def. It starts with def, and then you have to give a function name, def function name. So it starts with the keyword def, and a function name has to be given, any name that you want. Then we write the arguments that the function takes, and so on. arg1, arg2, all the way till it can take any number of arguments, right? Then you get a semicolon. Once you get a semicolon, you press enter. You need to have one tab space when you enter into a function, because it is part of that particular block of code. We need to give one tab space, and then we write our statements here. Statements that need to be executed again and again should be written here. That could be statement 1, and then we could have statement 2, statement 3, and so on. And then in the end, after computing some result is obtained, and then what is supposed to do is we're supposed to return result, right? This is how you will write your block of code, block of function. So it starts with your def keyword, then you will have a function name, then you will have the arguments that the function needs. Then you will have the set of statements that need to be repeated for a period, again and again. Once that is done, if you have to return something, if that function has to return something, then we calculate that particular result and we return it. So in the end, we'll have a return statement, and you should take care of the indentation. One tab space for all the statements in your function block. This is the syntax. Oh, shit. So how would you read the above syntax is: a function by name func name is defined which accepts arguments arg1, arg2 all the way till argn. The function is documented and it is a document string. That means whatever you write inside the function as part of your body. So this becomes your function header, this is your function body, and then you have your return statement. These three things will remain constant for every function. So let's say I want to write a function that will return the square of any number, right? So I have my def here. This is your first example of a function. I have the keyword def, I have a function name which is square of, and then this is my only argument that I'm passing. I'm passing only x, and then I'm returning x into x, that is x square. So this function basically will give you the square of any number. Similarly, I can have cube also. So cube of x, this will return x into x into x, which is x cube. So these are some of the examples of functions. Now how do I call this particular function? So to call this particular function, I just have to write the name of the function and pass my x values. Suppose I want the square of 5. When I execute this, I'm going to get 25 because the function is defined as such. It says return x into x. So anything that you pass to this function, right, it is going to return the value. So this becomes your function call. So this is your function definition. I have two functions here, one for square, one for cube. So this is your function definition, and how do you call that function is through a function call. That is, you just write the name of the function and then you pass the arguments that it takes. Suppose I want to store this particular value in some place, then I can also store it in some variable. So whatever this function returns will be stored in a variable called temp. And if I print temp, I'm getting the same output, which is 25. So if I want to call this function, again it is, instead of square of, I need to have, I'll write this here, I just need to call cube of, and if I pass 5 again, I'm going to get 125. As simple as that. So the syntax is very important. You have your def, and then you have the function name and your arguments, and then the return statement that the function needs to return. Right? Like for this particular example, I have two print statements here which are saying, hey Rajat and Rajat, how are you? Or how do you do? So instead of writing the above two statements every time, so if your program will, if you are using these two statements very often in your program, what you can do is, you can write these two programs or these two lines of code in a separate function and call them every time. So instead of writing the above code every single time, we can actually replace it by defining a function which would do the job in just one line. So this is what we have done here. I have defined a function called first func. Again, it starts with def first func, and then I'm printing the two statements that are printed here. Now, as you can see here, a return statement is optional. Only if you're trying to return a value, you should have a return statement. Otherwise, there is no need for any return statement. So this does not need a return statement. I'm just calling it, and every time I call it, these two lines are executed. So how do you call that function? It's using the function name. That's first func. So if I execute this, it is straight away printing those two lines. So anywhere in your program, if I need to print these two lines, or if you have lines of code that need to be executed again and again, instead of printing them every single time, I can just call this function. So suppose I want to print them like 5 times, or you are printing these lines 5 times in your program, I can just call this function 5 times and it prints the same statements 5 times repeatedly. This is the use of so these are called, functions are called reusable modules of code that can be used again and again depending on your requirement. Is clear? The syntax, pretty simple. Okay, a small variation here. For the same function, I am passing a name and I want this to be interactive. That is, I want to pass a particular name and I want the following to be printed. Instead of Rajat or anything, it has to be dynamic. That is, it has to print the name of the user. Right? So for that case, what I'm doing here is, it is the same function, but I've just made one change, that instead of not taking any argument, it is actually taking one argument now, which is a string. You don't have to define the type here. You can just pass a variable. So here, as you can see, it takes one argument, which is the username, and then it is printing a, and then it is inserting that username here, the variable, and then exclamatory mark. Again, it is inserting the username plus a comma and then one string called how do you do. So now to call this function, again I have to call first func and pass a particular string. So if I do this, automatically here username is replaced by the string Shreyas. Right? So this is an argument, and again this is not returning anything because I just wanted to print these two lines. right? Now if you want to make it even more user interface like, then I can use my input. If you remember from the first class or second class, this is to take input from the user. If I want to take input from the user, I have to use my input command, and then whatever you pass here will be shown. Like in this case, it is waiting until you enter a name, and whatever name I enter will be stored in a variable called name. So that happens here. Yeah. So now what I want to do is I want to take the user's name, I want to store it in a variable called name. Then I want to pass that particular name to my first function. In that case, first I have used my input function and I've taken input from the user, and now I'm storing it in a variable called name. The string that the user inputs is being stored in the variable called name. Next, what I want to do is I want to use this first func and pass whatever the user entered there. So if I execute this, first it is going to ask you, please enter your name. Whatever I enter, I press enter. I just restarted the kernel. So yeah, so it's asking, and then I enter any name here, and it will. First, this line is executed. Your input, whatever you enter, is stored in a variable called name, and then I'm passing the same name variable to my first func. Right? Pretty simple. Now we can also have functions within a function, nested functions. For example, in the same function, right, your first func, I also want to have another function which is def second function, and what I want to do is I just want to simply let's say, what should I do here? Let me just print something. This is second function, right? I have this. So inside my first function, I have my second function. Now let's see what happens if I call my first function. So just this much is printed because I'm only calling this function, right? I have just called this function. That is why these two lines are printed by replacing the username with this particular string. Now if I want to call this function also, then it has to be done either inside this block or outside of it. So here I can actually call my yeah. So as you can see here, I have my first function, right, which says, hey, these two lines are part of the first function. Now if I want to call the second function, I have defined the second function inside my first function. Again, you should notice the indentation here. Here one tab space, and again in the nested function also we have a second tab space. So this becomes your nested function. One tab space here, and again inside first function I have my second function, and for statements inside the nested function I need to have two tab space, one and the other. And then after that this function has to be called. So to call that function, I am calling second function below it. First I'm defining my first function. After that I have defined my second function, which is inside my first function. Now this function has to be called. So that I am doing as part of my first function, which is, so this, as you can see, is outside of second function. Anything that has got to do with second function should be at this indentation. But since I've called it, I'm calling my second function here. It means that the call is outside a function. So if I execute this, these two lines are part of the first function, and so this line is executed, and then this line is executed, and then this function is defined, and then this function is called. So this could be a function call within a function call within a function. This is also your function call outside, for the main function. Okay, is this clear? Nested function. Any doubts in this? Huh? You want to call okay, let's try what happens here. No, because here the way I've defined it is the scope of this particular function is inside. It is not outside of this function. So to access this function, either I have to use this function, or I'll have to declare this as a global function itself. Then I can access elsewhere. But because I've defined it inside this function, I can only access it once I'm inside this particular first function. Okay. So this is, so one more example here. I am simply multiplying two terms. Here I am passing two arguments, xy. Let's take three, xy and z. It takes three arguments, three integers, and what I am calculating is some say ss, which is x into y into z, and then I am returning ss. What this will do is, if I pass three numbers, it will multiply them and return the product. So to call it, again I need a function call here. So if I want to call a function, I have to use the function name and then pass the arguments. Here I am passing 4, 5 and 6. So it is giving me 4 into 5 into 6. Okay. So okay. Now let's see what happens if I pass this. This function here takes three arguments, right? What happens if I pass only two? It is giving you a type error. It says times missing one required position argument z. That means I need to pass three numbers, else it's not going to work. What happens if I pass 4? Again it says it takes 3 but 4 were given. And because it is x, y, z, I have to only pass x, y and z. Now it's going to give me that much. Right? This was a simple function. Now, since there we try to deal with variables and integers for functions. Now let's see, can we handle list examples using functions? Now for example, I have this list, right? I want to write a function which will take this list as an argument, not just a variable but the entire list itself, and it has to be able to calculate the highest element in this list, the lowest element, the first element and the last element, right? So this particular function takes a list, any list. It could be L, it need not be that it has to have the same name as this, any other name I can take. And when I call the function, this so when you are dealing with functions, whenever you have this, right, this particular parameter or your argument, the value that you call the function with will be replaced with that particular value. Like in this case, when I call, just execute. So I have defined this function here. Now if I want to call this, whatever I call this with, right? If I call it with eg list also. Now when I call this function, this particular a is just a reference to this list. So it need not have the same name as the list. So when I call this function, as you can see, because I am returning three things. I am returning the highest, which is max of a, then the lowest, which is min, then your first element, which is done using indexing, a of 0, then your last element, which is a of minus 1. So I am going to calculate these four results, and then I am returning all four of them. I am returning all four of them. So, and when I call this function, which is, and I pass any list I want, I can pass a new list also. I can just pass and something. So I don't have to pass this eg list itself. I can always pass a new list also. I am calling this function with a new list here, and it is calculating the highest, the lowest, the first and the last in the same order. It will always return in the same order. Okay. So now whatever this function returns, if I want to again store it back in variables, it's not necessary that I need to have only one return statement. As you can see here, I have four return statements. I'm returning four things. And here also, when whatever it returns, I want to store it. So I can use the same names here. Last equals eg function. So whatever this function returns, the first value, which is the highest, is again stored in one variable called highest. Again, your lowest is stored in lowest. The names are different. Again, I can give A, B, C, D also. I can give A, B, C, and D. Now, this is how it works. I have stored all these four variables in these all these four return statements in these four variables, which is A, B, C, D. Now, if I print A, B, C, D, I have the same values. Right? So I can have multiple arguments as well as multiple return statements. So this was a function. This was an example where I have two arguments and just one return statement. That is, I am returning only one value. So I can return multiple also. This is the example for that, where I take one list, but I am returning four values. Okay. So this is about multiple return types. Okay. The other thing is something called implicit argument. Implicit argument, what it does is, if in any function, right, if one of the variables has to be a constant, then we can actually declare it here itself. That is, y equals 3. When I declare y as 3, I am passing two things here. One is x and one is y, but the value of y will never change. Suppose, for example, I want to calculate what is 3 raised to power x. In that case, my 3 will not change. So I can always keep this as a constant. I can always declare y as 3. If I declare y as 3, then that becomes an implicit argument. That is, in the function call itself, I am defining y as 3. If I define y as 3, then the value of y will not change at all. And what I want to return, before that I want to calculate something. I want to calculate power of 3 power x, right? So that, which is your y, which is 3 power y comma x. So this becomes 3 power whatever you pass. And then I am returning, I will store this in something called temp, and then I will return temp. So this becomes an implicit argument. Implicit arguments definition is when an argument of a function is majorly common or same in most of the cases, or is a constant, we will use something called as an implicit argument, where we will define the value of that argument in the function header itself. Like here I'm defining y as 3. The value of y will not change in this. And then I'm calculating y power x. Whatever I pass here x, I'm calculating y power x, and then I'm returning the same variable temp. So if I execute this now, or if I want to call this, then I need to call this function and just pass 4, right? Because y is already fixed. It will not ask for 2 arguments now because I've already fixed the value of y. It is an implicit argument, and if I pass 4, it is returning, what is 81? It is 3 power 4. Or suppose I want 3 power 5, then I just need to pass 5. That becomes your implicit argument, which is y equals 3. Any doubts in this? So this is implicit. Right, but in most of the cases, the number of arguments that a function accepts is unknown. If you don't know if it takes 1 argument or 2 arguments or 3, then all you have to do is I have to keep an asterisk symbol followed by args. If you define it this way, this is Python 2 problem, it has to be bracket. So what this will do is, any number of arguments you pass, it will work because I have defined it as such. I am saying this, I do not know the number of arguments for this function. That is why I have placed a star with an args. So if I define it in this way, the above function accepts any number of arguments, and what it does is it will define a list, and for every element that you pass, it will add to that list. After adding, it will print that list and it will return the sum of all the elements. As you can see here, I have initialized inside my function, I have initialized a variable called res as 0 and then I have initialized a list also called res list, and then for I in args, we did this I think in the last class, for loop for item in list. So in this case, for I in args is here. If I pass 10, then I will iterate through every element in my argument list. I am saying resList.append of I am appending every argument that I pass into a list. I am printing that list and I am returning the sum. So if I actually, to call this function, as usual, I just have to pass, I have to call that function add underscore n, which is the same name here, and I can pass any number of arguments here. Keep on working. So it will print that list and it is going to output the sum as well. It has 2 outputs. I can say is so I mean this is not the sum, this is the list of yeah, so this is the list of elements passed and then the sum, that is returning the sum, right? So this will work for any number of arguments. If I don't know if I have 2 arguments or 3 arguments, I can always give a star args which will work for any number of arguments. So again, a small concept here, global and local variables. Whenever variable is declared inside a function, whenever a variable is declared inside a function, it becomes a local variable. That is, the scope of the variable is only limited to that function. For example, if I have this function called some function and I have a variable called var and I have initialized it to 100. right? This is all I have. Now inside this function, this variable has a value 100, but outside of it, if I create another cell and if I try to print var outside the function, it says it's not defined. But because this is a local variable, it is only the scope of this variable is only limited to this function AA. That is called as a local variable, where the scope of any variable, if it's declared inside a function, is limited to only that function. Then it becomes a local variable. Global variables meaning it is defined outside of it. Here if I define var as 100, and then in the next cell if I check or if I print var, I get 100. This is a global variable because it is outside of the function. If it's inside the function, it becomes a local variable. Outside of it, it becomes a global variable. This we have done. So. Right. So. Okay. One of the important things in functions is your lambda function. Lambda functions are basically, they are small functions. You do not need a name for it, right? If I have to execute some small like two statements of code or single statement of code, they are also called inline functions. If I have to execute a small function block anywhere in my program, instead of writing a big function, I can use something called as a lambda function. Lambda functions, the syntax is, the definition is, they are not defined with any name and they will only carry a single expression, right? It will carry a single expression whose result is returned, and they come in very handy if you are trying to operate with lists and arrays. Now, a small example of this. Suppose in my function, I just want to calculate x into x, the square of it. In that case, to write a lambda function, I have to start with the keyword lambda, and then I have to define one expression, right? Or first I have to have a result, and what should be added to the result is something like this. This is what I need to add to my result. So whatever I pass here, I can actually store this in something called some variable. Let's say again result equals this way, and then if I want to call it, I just have to call result, and if I pass 100, it will give me, sorry, this is, yeah. So these two should have the same name. How I want lambda and then one expression here, and whatever I get after calculating, I have to store it back in one variable x, and then that will be stored in your result variable. This is your entire one line function, or it's called as an inline function. If I want to call this, I have to use this particular function name. Now this becomes your function name, which is result. Now to call this, I just have to pass result and pass any value that I want, and the value is obtained, which is the square of it. 1 second. Like for example, here I have z such that now this entire your z becomes a function. If I execute this and if I check the type of z, it says function. So z itself is a function here. It is a lambda function because I have defined it that way. I am saying z equals lambda x such that x into x. So whatever expression is calculated here, the value is stored in x, and the function is called by the name z. So if I want to call this function, I have to use this z variable and then pass any argument that I want. So if I pass 4, I get 16. So this is the syntax of lambda function. Function name equals lambda and followed by x and your expression. And whatever is calculated in your expression, right? Whatever this expression evaluates to is stored in x, and then whenever I call this function, this particular x will be replaced by that value. Like for example, here I have z, right? And I want to, if I pass z of 4, then your x basically becomes 4. I get 16. When I call z with the value 4, that means first of all this x, it goes to the expression part of it, where x into x is replaced by 4 into 4, and then that value is stored back in x, and that is returned as part of your z function. This is the syntax of your lambda. They come in very handy if you're trying to deal with lists. We'll see how. This is another example. I have y equals lambda s, and what I want to do is I want to multiply whatever I pass here by 34. So in that case, lambda s such that 34 into s. Now if I call y of 45, I am getting 34 into 45. As simple as that. Is this clear? The syntax of lambda. Any doubts in this? What is it used for, and its use cases and all. Now, I told you that lambda functions are mostly used with data structures like lists or arrays. So we'll see how that is done. We have another function called map. What this map function does is, if I have a list, suppose I have a list here, like list 1, right? And I want to perform a function, or I want to perform a specific function for every element in this list, right? For every element in this list, I want to perform a function, or I want to execute a function by calling every element of this list. So in that case, I can use my map. So map function basically executes the function that is defined. For example, your let's say z is defined, right? We have z defined here, or rather y. I have y defined here. So I want to apply this y for every element of list 1. Y is a lambda function. I want to apply this y to every element of list 1. For that purpose, I will use your map function. So what this map function does is, it will basically execute the function that is defined, which is your y, to each of the list element separately. That is, it will apply your y to each one of 1, 2, 3, 4, 5 till 9. To call that function, I have to first call map. Inside that, I have to use lambda and the function name, which is y, and then my list 1. So if I execute this 1, why should work? Yeah. Right. So here, to call this particular function or to use map, then first of all, as part of my argument for map function, I have to first pass my lambda function, which is y, which I have defined before. Y equals lambda s such that 34 times s. Then I pass my data structure, which is a list. What this will do is, for every element in list 1, it will multiply it by 34. Now the resultant of any map function is a map object. The resultant of any map function is a map object. We cannot directly visualize it. The best way is I can put it in a list or a tuple. What I'm doing here, three things. One is I'm defining a lambda function first of all, right? What I want to do here is, my objective is, I have this lambda function. I want to apply this lambda function for every element in this list one. To do that, either I can use a for loop and call it again and again, or I can simply use a map function. Now this is what this will do is it will execute the function for every element of this particular list. So first of all, I've defined my lambda function. I have my list. Then I'm calling my map function. I'm passing the lambda function first and then the list. The resultant of this is a map object which cannot be seen. So we'll deal a little more with map objects in probably the next class. Because it is a map object, we cannot visualize it. If you want to visualize it, we have to convert it into a list. So I'm doing list of that. If I do list of this, I've got, so this is, the first element of this is 34 into 1. The second element is 34 into 2, 34 into 3, all the way till 34 into 9. Okay. The other way is, here instead of predefining y, that is my lambda function, I am defining y as part of my map itself. This also is possible. Here I have my lambda function defined. The only difference between this and this is, here y was predefined. Here I am actually defining my lambda function inside my map, lambda such that x into x, and then I'm passing my list one. So what this will do is, it will give you the square of all the elements. It's exactly the same thing, but the only difference is I had y defined previously here, whereas here I am defining my lambda function as part of the map statement, map map function. Is this clear? Map, how to use lambda functions with map. This is a very favorite question for interviews. So they will ask you about this lambda function and how to use list with lambda functions, for which we have to use maps. Okay, so functions is covered. I need I think 20 half an hour more for generator functions, which we'll probably do tomorrow. So I don't want to stuff too much. Generator functions is left out. Just a small topic, like 10 minutes. So tomorrow again we'll start with statistics tomorrow. Statistics or probability, one of the topics. Okay. Also we have class and objects. That also is left, right? Okay, then we'll do one of those tomorrow. Either statistics and probability, part 1, or Python class and objects. Object oriented Python. So that's it. Anybody watching match today? 11 for 1. Yaar out? Chalo. Tomorrow we'll start at 4 to 5. I'll share this particular notebook.